standardize our input variables. So define sc equals to standard scalar, and here we must fit our data to it. And here we execute it on our train data and define x underline train underline standard as follows. So sc transform, and here we must input x train and define again this method for x test. So here sc transform x test. Then we must build our logistic regression model. So define logreg as follows equals to linear model dot logistic regression, and we create our model. Then we have a straightforward like previous lectures. Here we must fit our data in this model. So here use x train standard and y train, and finally we must predict the output of our method as follows. So write logreg dot predict, and here write x test standard. Now we can see the some accuracy method and measurement. So write c underline m equals to confusion matrix of our method. So here write y test and y pred. Then we can print it, and we can build our codes to see the output. As you can see, we have a good confusion matrix. If our data are this place, we must have a good accuracy. We have a triangular matrix and we only have one misclassified object. So we continue to R squared and classification report as follows. Similar to previous, define R2 as follows. R2 scores of y test and y pred. Then MSE equals to mean squared error of y test and y prediction. Then we must use classification report as follows. So write classification report of y test and y pred. So copy and paste it here. Then print all of them. So write R2, write MSE, and write C underline R. Then execute all of these codes. Okay, we have a good accuracy. The error has been changed from the previous because we have a 100% classification here, and as you can see we have a 9 class, 0 from 8, 0 from 8, and we have a good accuracy. We can build it again to have some error, so wait to see the sum error. I hope we have some error here, but not. So alright, we make a good logistic regression method based on built-in database of Python and Sklearn. We can make it better by using plot functions. So add the plt dot figure and define fixed size 9 by 9, then use SNS or Sklearn to see the heat map of this method. So here we must use confusion matrix, and here use not equals to true, and color map equals to blues underline R, and finally use plt dot show to see the output of your codes. So build it again. As you can see, we have a good heat map here and we have a no error. In the next lecture we use real world example, and you see that we have some data here and here, and we have errors. So it is very good for first step, and keep moving forward to create such a model to build your logistic regression model to classify your data. And stay tuned to the next lecture, and thank you.